Hi, welcome back. We're continuing to look at solving exponential equations. In this video, we are going to look at an example that's a little bit trickier than the previous examples we've looked at, and that's because there's more than one way I can solve this. So our first step, identifying a common base. So I am looking at 4 and 64. So looking at these two things, I know that I can write 4 as 2 to an exponent, and I can write 64 as 2 to an exponent. So I am going to work with a base of 2 here. So I'm going to start by working with a base of 2, and then I'm going to see if there's anything else I can do. So this gives me 4 is 2 squared raised to the 2n minus 1. And 64 is 2, 4, 8, 16, 32, 64. So it is 2 to the 6. So simplifying 2 to the 2 times 2n minus 1 is equal to 2 to the 6. My bases are the same. 2 times 2n minus 1 is equal to 6. Distribute in. And 4n is equal to 8. N is equal to 2. Okay, so this was using a base of 2. But what if I looked at this and I identified that 4 cubed, so 4, 16, 64, is also possible. So instead of using a base of 2, I'm going to use a base of 4. And my question is, does it matter? All right, so if I use a base of 4, over here on the left-hand side, nothing changes. So I have 4 to the 2n minus 1. And 64, I can rewrite as 4 cubed, 4, 16, 64. So I have my bases are the same. So 2n minus 1 is equal to 3. 2n is equal to 4. N is equal to 2. And what I want you to notice is that both ways, whether I use the base of 2 or a base of 4, I end up getting the same value. So as long as it is a valid base that works for both of them, you can use it.